Okay. This was a question on WebAssign. I believe it was number 10. Several of you seem to have difficulty with it, so we were asked to find the points on this graph, that have where the slope of the tangent line is this. That was a question. So, most of you, I think, figured out I need to figure out what the slope is. 2x plus 2y dy dx equals 0. And then if we solve that out, we get dy over dx over y. Okay? Now, the slope has to be 9/40ths. We found the derivative to be this number, right? So, makes sense that we do this, right? Negative x over y equals 9/40. So if you did that, many of you jump to the conclusion x is 9, y is 40. Or some of you probably jump to that conclusion. Okay? Slight problem with that. If I put, what else does it have to do along with having a slope of this, what else has to be true? What? That's right. X squared plus y squared has to equal 81. Well, 9 squared plus 40 squared is real quick to decide that it's not equal to 81. So, what do we do now? Here's my suggestion to you, or here's what I suggested. Let's solve this for x. X is the easiest one. So, x is 9/40 times y. Negative x is that. That's just multiplying both sides of this equation by y. So, that means x is negative 9/40 y. Agreed? So now we need to plug this in to our equation up there. Negative 9/40 y squared plus y squared equals 81. We okay with that? Now what can we do? Well, if we square this out, we get 81 y squared over 1600 plus y squared equals 81. Now we've got to use a calculating device, figure out, if I add these two together, so I get 1681 y squared over 1600 equals 81. I don't know what that is, but you can figure that out. All right. Oh, yes. Well, yeah, what will we do now? We can multiply by 1600, so 1681 y squared equals 81 times 1600, and somebody can tell us what that is? Can somebody tell me what 81 times 1600 is? If you can, I'll just move on to something else. Come on, people. 129600. So what are we going to do now? And when we divide it, we get what? 77.09. Did it stop there or did it keep on repeating? Keep repeating. Okay, so let's do this. Let's leave it as 129600 over 1681. And now what do we need to do? Square root. Well, if we square root, what are we going to get? What's the square root of 129600? Okay, so it's the square root of 129600 over, what's the square root of 1681? 41, I think. So y is plus or minus these two numbers. Agreed? Well, can I get x's to go with that? Yep, if we plug this back in over here, I get x squared plus 129600 over 1681 equals 8. And I can work through that. But here's the problem with all of this. I come up with 4 numbers. I come up with something for x, comma, square root of 129600 over 41. I come up with that same something and the negative of that. I come up with the negative of this number and this thing, and I come up with the negative of that number and the negative of that thing. So I come up with 4 points. I've only got 2 answers. How do I know which 2 I have? Well, let's go back up here. What does this graph look like? X squared plus y squared equals 81. Circle. All right. The slope is 9 over 40, which is positive. So I've got a circle, and I want the slope to be positive. Can the slope of anything in here be positive? What about over here? So I know it's got to be something that's in this quadrant, something that's in this quadrant. What's true of numbers over here? The x coordinate is negative and the y is positive, right? So it's going to be this one right here. What's true down here? The x coordinate is positive and the y coordinate is negative, which is going to be this one right here. So that was all of the thought processes you would have to go through to solve that problem. And on any week but Spirit Week, you would have been able to do it. Okay? Now I want to spend a few minutes reviewing, working some more of the logarithmic problems like we did yesterday. What's the derivative of the natural log? 1 over x. What if it's something other than x in there? 1 over the argument times the derivative of the argument, okay? So let's take an example, take a simple example to begin with. This is still in 14, so you need to work along. Wake up, Terry. You need to work along and get through these things, okay? What did we say we want to do before we try to tackle something like that? Because if we treat this as our argument, what happens? Will we get the right answer? Yes. What's the difficulty of taking the derivative of the square root of 3x minus 5? Is there a difficulty? Come on, people. We have to use the chain rule in there. Is it difficult? It's just a few more steps. What did we decide we could do to simplify our life so that it was a little bit easier to take the derivative there? Right. We went back to the and we used our log properties that we have. Our log properties. And one of our log properties said if we have something that looks like this, x to the a power, and we're taking the log of that, we can move the exponent down in front and make it a times the x. So what power is 3x minus 5 being raised to right now? 1/2. So we can make this 1/2 times the ln of 3x minus 5. Have we done any calculus? No. All we did is we went back to using log properties that we learned in previous classes. That's all we did. So we haven't done anything calculus yet. Now, we need to take the derivative. All right? So if we're trying to take the derivative of this, what do I do with this 1/2? It stays there. Some of you are saying, I got to use a product rule, right? Well, product rule, derivative of 1/2 is going to be 0. So, yes, ma'am, question?
Sorry. For the ln x to the a is equal to a ln, what's the ln above?
That was kind of a title that I wrote up there. Yes, that means absolutely nothing. So, we know that we're going to need the 1/2 here. Just like we know if we've got a function equals 5x, the derivative is going to be 5. Because the derivative of x is 1 and 1 times 5 is 5. So we know we're going to have 1/2 times the derivative of ln. The derivative of ln. 1 over the argument. 1 over the argument. Right? Times. What's the derivative of the argument? 3. So how would we clean that up and make it look a little bit neater than 3 fractions being 3 things?
3 over 6x.
We could make it 3 over 6x minus 10, or you could leave it as 3 to 3x minus 5, 2 times 3x minus 5. Either of those answers would be acceptable. Remember, we talked about this makes taking derivatives easier sometimes because we can use our log properties. So as another example, I still don't want to do that one. Let's jump over here to some of these that we did not do. Something like the ln of t plus 1 quantity squared. The ln of t plus 1 quantity squared. Just find that derivative right quick. See if y'all remember anything from Monday afternoon. Jamie Lee, what's the first thing you're going to do? Yes. Put the 2 in front, so it's 2 times ln of t plus 1, okay? Now, Stella, what are you going to do to take the derivative here? So our final answer would be 2 over t plus 1. Do I write y prime or dy dx there? Does it make any difference? Doesn't matter. They're both standing for derivative, okay? So just understand that both of those mean the same thing there. Good, good, good. This looks a little more challenging. Why does this problem look more challenging, Sutton?
Because it's to the, is that, oh wait, it has x times a, x squared minus 1, and there's an exponent in there, so it'd be x squared minus 1 to be 1/2 times x.
Yes.
The natural log of that.
So we've got, our argument, the thing on the inside here, how would we take the derivative of that thing on the inside?
Would we multiply 1/2 x times 2 or x squared minus 1?
Yes, but if we're checking just the derivative of this problem, what do we have to do here? Product rule, and then taking the derivative of this thing over here is chain rule. It gets nasty. What can we do because we have natural logs in here, though? Again, go back to our properties on the first page of this. If you haven't learned those properties yet, I'd take a screenshot of them and put them somewhere for you to refer to on a regular basis. If we've got the ln of a product in here, we can simplify that to ln of x plus the ln of x squared minus 1 to the 1/2. We're not going through how we got these properties. You got them in previous classes. Yes?
Would we move the 1/2 to in front of the ln?
Exactly. That'll be our next step. So the first thing we can do, the fact that it's a product between these two, we can write it as ln of the first thing plus the ln of the second thing. We haven't done any calculus yet, people. Now we're going to take the 1/2 down in front. ln of x plus 1/2 ln of x squared minus 1. Is there any other algebraic simplification we can do here? Nothing else we can do. Why can't I split up the x squared minus 1? It's in parentheses and the subtraction is inside the argument. We don't have a rule for how to break up if the subtraction is inside the argument. So now we're ready to do calculus. What's the derivative of ln of x?
1 over x.
1 over x. What are we going to do out here?
1/2 times 1 over x squared minus 1 over 2x.
Are y'all okay with that? Does this make more sense than it did Monday afternoon now? Y'all were weeping and moaning on Monday. How could I say this even more?
4x cubed minus 4x. At the bottom, my bad. It'd be 1 over x plus 1 over 4x cubed minus 4x.
Where did you get the 4x cubed from?
This is when you do 1 over 2. Oh, wait, I see what I did. Never mind. Yeah, I see what I did.
Because this 2x is in the numerator, this 2 is in the denominator. I can cancel those 2's. Agree with that? And I can get x over x squared minus 1. Now, this is one where you need to be able to simplify that. Because that's not on your multiple guess answers. But we've done nothing wrong yet. So what do we need to do to simplify that? Common denominator, okay? What's y'all's terminology for adding these fractions? How do y'all do that? Does smiling x ring a bell? Does getting a common denominator? What makes you happy there? I want to make you happy. Okay? Smiling x, if you've never heard that, we're going to multiply this thing times that. We're going to multiply this thing times that. And we're going to multiply those two things together. Since we've got two fractions, we're multiplying denominator times numerator, x squared minus 1. Denominator times denominator, plus x squared, over, multiply the denominators together. And that could be simplified a little bit more, couldn't it? 2x squared minus 1 over x squared minus 1. All right? So you should be able to recognize that answer there, okay? If you can't recognize that answer, then you've got a problem. If you said get a common denominator, you'd get to the same answer there, okay? It's just a shortcut when there's two fractions there. All right, I feel pretty good about what y'all are doing here. Now there is a web assign. There is a web assign for this stuff due Monday, maybe? Does that sound about right? Okay, so you don't panic just yet. You're going to have opportunities to ask questions about all of this, okay? But we do need to spend a little bit of time today talking about something that's easier, something that doesn't require anything that we talked about before, okay? This is 15. Some of this you've already heard before. Some of it we're just going to tie together. I really just want to answer a few questions. This is a lot of physics. So those of you that go down the hall to physics, this is should enhance or help you with that, okay? Average velocity. The average velocity is what you have calculated all of your mathematical life up until now when somebody says, how fast are you going? The average velocity. To find the average velocity, you take how far you've gone divided by how long it took you to get there. How far you've gone by how long it took you to get there. And that gives you your velocity. That doesn't give you your velocity along the way, does it? Because you stopped, you were at 0, so you had to be going speeds in the middle there. Okay, so let's take a problem and look at finding the average velocity of this. So if this is our position, and we down here in calculus use S to stand for position. No, I don't know why. It just is. All right, that's the position of this object at any given time. So at t equals 0, how high is this object? 160 feet. At 1 second, it's whatever 160 minus 16 is, okay? So average velocity time interval 1 to 2. What would you do? It's how far you've gone. Not how far we've gone in 2 seconds. How far have we gone from 1 second to 2 seconds? So, how would you do that? If you knew where he was after 2 seconds and subtract where he was after 1 second, that tells you how far he's gone in that 1 second, doesn't he? Divided by his time that he took, his 2 seconds minus 1 second. So let's do that mathematics there. If we find S of 2, putting 2 in here, 2 squared is 4 times 16 is 64. 160 minus 64 is 96. 96 minus, if I put 1 in here, 1 squared is 1 times 16 is 16. 16 minus 160 minus 16 is 144. Divided by 2 minus 1, which is 2. So 96 minus... Oh, sorry. 96 minus 144 is... negative 48 divided by 1. Why negative? Because it's dropping. Now, for those of you that aren't down in physics, explain to the rest of us, what's the difference between velocity and speed? It has direction to it, okay? When you come there, your directions are things like 30 degrees north of east or 45 degrees south of west. Here, in this class, your directions are positive and negative, Okay? If we're talking about going up, the velocity is positive. If something going down, the velocity is negative. Same thing with positive, negative position is down. What about if we're moving left and right? Moving to the right, y'all's right, this is a positive direction. Moving to y'all's left, that's a negative direction, okay? So that's how we talk about direction here. So using these same steps, find the average velocity of between 1 and 1.5. How would you do that? And you will be asked to do these things on FRQs very soon. As soon as Friday and as soon as the next test. Yes? All right, 96 we got by plugging 2 right here. We said negative 16 times 2 squared plus 160. That's negative 16. You see me now? I'm just going back and using this equation that I gave you. S of 1.5 minus S of 1 over 1.5 minus 1. Do I always have to do 1.5 minus 1, the greatest time minus the smallest time? Would I get the same answer if I did 1 minus 1.5? If I change the order of these, I can change the order of these. It's just like finding the slope. Do you remember your slope formula is y2 minus y1 over x2 minus x1? And it doesn't matter which point is x1 and x2 as long as you keep them consistent there. So what do we get for 1.5, anyone?
124.
Okay. 124 minus 144 divided by 0.5 is negative, what is that, negative 40? Yes, Jerry, question? Can everybody get to negative 40? I don't want any weeping just yet. Yes, ma'am. Minus 144 is negative 20, right? Negative 20 divided by half is negative 40. So, the average velocity, not the average velocity from 1 to 1.5 and 1 to 2. Why are they different? It's accelerating. The longer it drops, the faster it's getting. Would you agree? So what do you expect for this answer up here to be? It's going to be, is it smaller or is it larger? It's
Smaller absolute value.
Yes, it's going to have it's going to be smaller in magnitude. You expect this to be negative 30 something here. Okay? So it's going to be, the speed of it's going to be slower, but it's going to be going in a negative direction still, okay? So, could all of you handle this? Okay, all right, I'm not going to keep boring you. Instantaneous. This is calculus. This requires calculus. What's the instantaneous velocity? You already know. It's the derivative, okay? The instantaneous velocity is the derivative. So if this is our equation for position, what is the velocity? The velocity of it is the derivative. What is the derivative of negative 16t squared with respect to t? What does that mean? In terms of t. So what's the derivative of negative 16t squared plus 160? Negative 32t. All right? So what's the velocity after 1 second? Negative 32. So if you could time it specifically at 1 second, it'd be going negative 32 feet per second. And at 2 seconds, it would be doing negative 64, and so forth and so on. That's the instantaneous velocity of it there. What is instantaneous speed at 1 second? 32. Why isn't it negative 32? Speed doesn't have direction, okay? Speed is just how fast we're going. 32 in a negative direction there. What, good question. What is this? This is what y'all love doing, find the derivative using the limit process. The derivative is just finding, the slope is just finding the derivative, finding the limit. Let's back up and start over. The derivative is this limit, and the derivative is the same as velocity. Derivative of position is velocity. That's something you want to commit to memory because it makes things easier, okay? Now, we're going to talk about some things to memorize. All right? This is a memorization moment. Those don't happen all the time here. 1/2 GT squared plus V naught T plus S naught. That's my terminology. Okay? V sub 0 is the initial velocity. S sub 0 is the initial position. Okay? Now this formula always works if something is free falling. What does that mean? Nothing's acting except gravity. So if you walk up to the top of the Empire State Building and drop a penny off and the wind doesn't blow it, we're assuming no wind resistance, this is how that penny is going to act all the way down to the ground if there's no wind resistance on it, okay? If you drop a brick, if you drop a human being, anything that you drop, assuming the wind doesn't change it, this is how it's going to react all the way down, okay? What is G? Depends on what your units are. It's negative 32 feet per second squared or negative 9.8 meters per second squared, assuming we're on the Earth. We don't travel off the Earth very often in here. So that's just something to memorize. Now I think I have, yes, I did this right. These are critical questions that I want you to be able to answer because these are always fun problems to me. But you need to be able to answer these questions and refer to them. So just think about this. When an object traveling upward reaches its highest point, describe its velocity. Okay? Everybody agree with that? How do you know when it has reached its highest point? Ooh, now y'all said two different things. Well, no, you didn't. Velocity is 0, stops moving. Okay? So, watch this. This was its highest point, according to y'all. It stopped. Okay. Where's its highest point? How do we know when it reaches its highest point?
When it starts becoming...
When it starts coming back down?
When it goes from positive to negative.
Would y'all agree with that? Because this is not its highest point right here, is it? Okay? Its highest point is up here. How do you know this is its highest point? What'd you say? Because it starts dropping. Now, can you quantify that with something here? How do I know when it gets to its highest point? The velocity's got to get 0, yeah. What else has got to happen?
It's going to become negative.
And the velocity changes signs. I'm going to put it a little bit more generic with that because it's going to help us later on, okay? So what has to happen to reach a highest point? Now, you're right. I can see the wheels turning in some of your head. Gravity is not going to let something stop right here and then start back up. I agree with you, okay? But I'm trying to work a little bit more generic. Think about it in this vein here, okay? I'm walking that way. I want to know what the furthest distance is I walk that way. So, if I stop and start back up, the furthest distance is not back there. When do I reach the furthest distance? When I stop, one thing, and I turn around. So it's not enough to just stop. That's one thing. That tells me I stopped. Then you've got to have a second thing. You've also got to turn around. Okay? Those two things there. And see, this kind of led in, wasn't planning on my part. This led into this second question. When an object traveling left or right, describe its velocity. Its velocity has to go to 0 And velocity is going to go from being negative to 0 to being positive. That means it's turned around. Okay? This is the one that's always harder, this third one. If an object is slowing down, describe its velocity and acceleration. So the speed is decreasing. Describe its velocity and its acceleration. Yes, sir? Let's just think in one direction, okay? I'm running this direction, okay? And I'm slowing down. Describe my velocity and describe my acceleration.
Velocity will always be positive and acceleration. Is it slowing down like
Get in your car. You're driving your car, okay? There's a red light in front of you. Okay? It's red. That means stop, okay? So what are you going to do? Describe your velocity. Describe your acceleration. Acceleration is negative. Ooh, the velocity is slowing down, but what does that mean? The velocity is getting small. It's not the velocity that's getting smaller, it's the speed that's getting smaller. But the velocity is what? It's about in your car. I'm moving that way. Is my velocity positive or negative? Positive. Okay? The velocity is positive because I'm still moving forward, but the acceleration is negative. Now, is that the only way to slow down? How many of you, your car was parked in a garage this morning? How did you get out of there? You backed up, hopefully, didn't you? If you went forward, you probably aren't here yet. Okay, you backed out this morning. Describe your velocity while you were backing out. The velocity was negative, weren't you? You're going backwards, so the velocity was negative. Okay, so now let's think about this. Going backwards. How am I going down? That's right. I'm backing up. I'm backing up. How do I come to a stop? How do I slow down from backing up? I've got to stop accelerating backwards, don't I? I've got to accelerate forwards. So if the velocity is negative, the acceleration has to be positive. So summarize that even more. Describe the velocity and the acceleration if I'm slowing down. They're opposite of each other. Okay? So you would simply say they're opposite signs, opposite directions, something like that. But they're opposite signs, opposite directions, depending on which class you're in. Okay? So if you know that the velocity is positive and the acceleration is positive, what can you tell me about something? The velocity is positive and the acceleration is positive. It is. What if the velocity is negative and the acceleration is negative? Still speeding up. I'm just going backwards faster, okay? Does that make sense with your car? If you're backing up and you press the accelerator to accelerate faster, what's going to happen? You're going to go faster backwards. If you want to slow down from going backwards, what do you have to do? Get your off the accelerator, put on the brake. You have to stop accelerating backwards. You have to decelerate. You have to slow down the acceleration. The acceleration becomes positive. This is information that you're going to need to refer back to either in your head or your notes as you look at FRQs going forward here, okay? So let's look at an FRQ. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above water, bless you, and the velocity of 16 feet per second. What's important in here? 32 feet above water, what is that? That's our initial position. That's where we ought to begin with, S sub 0. What else is important here? What is that, Josh? How do we know it's upwards? Very good. We're kind of assumption. We're pretty safe. It says he jumps. Now, jumps is normally upward. We don't say that it's negative. And if think about how many times have you seen somebody on a platform jump down? It's kind of hard. They normally jump up. So we're going to assume this is positive and they're jumping upward. Anything else important up here? T equals 0. It's a number, so it sounds like it ought to be important, right? So what is the position function? What is that asking for? What's my answer supposed to look like? Yeah, S of t equals something. Or S equals something. What's my position function? It's 1/2 gt squared. 1/2. What's it's negative 32. How do I per second? So it's 1/2 negative 32 t squared. And we can clean that up in a second. I'm just trying to help you write it down. Plus V naught t. What's V sub 0? 16t. What's S sub 0? 32. And I can clean that up to negative 16t squared plus 16t plus 32. All right?
Why G?
Because what are our units? Feet per second. We're measuring in feet, so it's negative 32. If in meters per second, then it would be negative 9.8. Okay? So now, when does the diver hit the water? What answer am I looking for? Time. I'm looking for a time. So what am I going to do to find the time? Set all what? Be specific. Set this function equal to 0. Okay? Nick says, let's set this equal to 0. Why do you think that's a good idea? Because the position has to be 0 to hit the water. We're setting the water as a 0 place because we were 32 feet above the water. That was up here, so 0. Now, forget about what we're doing here and look at this equation in your Algebra 2 mind. Negative 16t squared plus 16t plus 30. Tell me something. How many answers am I going to have? 2. So the diver's going to hit the water twice? One's going to be a negative time? There can't be anything. There can't be a negative time. What does that mean? But what does the negative time mean? Does that mean math is wrong?
Assuming that it was traveling at the same velocity the entire time, that was where it would have left the ground.
Yes. Does everybody understand what he's saying there? All right, let's think about a picture of this. Here's my platform. Here's my man. I'm not very good at men, okay? Or women. Drawing them. So what is he going to do? He's going to jump up and he's going to come down. Boom, like that. Assuming, as Josh said, what does this kind of look like? What does it kind of look like the graph of? Parabola. So assuming instead of starting there, he had started up back here. Then this is what like the rest of the way. So it's making the assumption, whatever we get, we're going to get 2 for this and negative 1 for this, I think, of here. So that means before he was here, if he traveled the entire time, that's where he would have been at. He would have been at ground level there. Okay, so find out. We can solve this problem because this doesn't take any calculus here. And if we factor that out, we get t equals 2 and t equals negative 1. Did somebody do that, or am I just remembering it? Negative 1 makes that 16. Nope, I've got those wrong backwards, don't I? 1, negative 1. Oh, no, negative 1 make that negative 16. Makes that negative 16. Yep. So 2 and negative 1. I think that's right. Y'all can do it on your own time if you'd like to. So when did he hit the water? At 2 seconds, okay? Now, what's the diver's velocity when he hits the water? Oftentimes, people want to say 0. Okay? Tell me how you got negative 48.
The first way I did it the physics way. The second time I did it, I took the derivative.
Okay? Did you get the same answer both times?
Yes.
Good. That means physics must be right. So velocity, we need to take the derivative. What's the derivative? It's going to be negative 32t plus 16. And at v equals 2, we get negative 64 plus 15, negative 48. Do we expect a negative velocity? Why? It's going down. Okay. Yes, ma'am? Do you see where I got the negative 32t plus 16 from? Velocity is the derivative of position. Here's my position function up here. The derivative of negative 16t squared is negative 32t. Derivative of 16t is 16. 32 becomes 0. The velocity at 2, I'm going to put 2 into this equation. Negative 32 times 2 plus 16, negative 64 plus 16, negative 48. Why isn't it 0? Because he's still moving. Does it bother y'all, or y'all just sit that far advanced over the classes I've had before? A lot of times people want to say he's going 0 when he hits the water. Why do you think he's going? Why do people want to think he's going 0? Because he stops. Yeah, if you hit a hard surface, very good. If you hit a hard surface, you're going to stop. Did you stop before you hit the surface though? No. The surface is what stopped you, okay? So if the surface hadn't been there, you'd have kept going. So this is the velocity. He is going negative 48 at that point. Okay, how did I get the initial formula? I went back to this. This is my base formula, always, for free-falling objects, okay? My gravity is either 3 or negative 9.8, depending upon my units. Okay, so we're using feet over here, so we're going to put negative 32 in here. This is initial velocity. He was started off at 16 feet per second. See, he was this high. And he was traveling at this speed. Oh, okay. You thought this 30 was going there. Okay. Sorry. Now it makes sense to you. Okay. My apologies. I've taught this too long. All right. Not too hard then. Good. Any more to look at there? We can solve these problems here. I'll give you 2 or 3 minutes. You just see if you can do it on your own, okay? See if you can do all 5 of these. All 5 pieces of this, and then we'll stop. Oh, is G a constant? Yes.
Is S of t the velocity at a certain place?
No, what's S of t, class? Yeah, but it stands for position, yes. S of t is position.
Okay.
Now, when it says determine the position and velocity functions, do I just write down negative 16t plus v naught t plus s naught? Plug in the values for v naught and s naught, don't you? Okay, good. Yes, sir.
Position when it's dropped or it's not before you drop
Now, we want a position function. We want something with t's in it up here. We want you to use this. That's our position function. Now, we don't want any variable in there but t, so it'll be negative 16t squared plus v sub 0 t. What's its initial velocity? Why 0? It's being dropped, so it'll be 0t. Now, you don't have to write that there, okay? But I'm writing it so you know that I'm not crazy here. Plus S0. Where did it start out at? 1,362, 1362. There's my position function. How do I determine my velocity function, Terry? How do I determine my velocity function now that I've got my position function? You mean? Yes, we simply take the derivative of the position. The velocity function is the derivative of the position function. Okay? So it's going to be what? Anyone? Negative 32t. Because the 0t would just become 0 out there. Okay, so there's A part. B part. Who wants to explain what to do there?
We'll have to plug in the, oh yeah, we have to find the difference in positions. So we'll plug in 2 for the equation up there, so like it'd be negative 16 times 2 squared plus 0 times 2 plus 1362.
Okay, so find the position at 2.
And then we'll find the position at 1. We'll subtract
Very good.
divided by the time difference, so that's 1.
How does Sutton know to use that formula? Yeah. What words cue him to do that? We got 5 different problems here. Average. The average velocity. Average tells us we don't need calculus. You don't need calculus to find an average. You don't need calculus to find an average. At 2, we're at 64. We are 1298 minus, at 1, we are 1346 over 1. Is that right? I don't know. Is that right? Isn't that the same thing we got a while ago when we did S of 2 minus S of 1? You mean the average velocity of anything between 1 second and 2 seconds is going to be 48? No? Oh, yeah, okay. You mean the anything in free fall? You mean if I drop a brick or if I drop Josh Hampton, both of them are going to average 48 between the first and second second? Yes. Okay, it doesn't matter how big they are. They're still going to have the same between S of 2 and S of 1. What's C part asking for? Instantaneous. What's instantaneous velocity, Rhett?
That's the specific one that one went over.
Yes, so how do we do that though? Instantaneous velocity. Derivative, yes. We want to know V of t, which we already know to be negative 32t. We want to know the velocity at 1 and the velocity at 2. That's not too complicated, is it? We plug 1 in there, we get negative 32. We plug 2 in there, we get negative 64. Y'all comfortable with that? All right, we'll finish, because what time does the bell ring? 5? We'll work a little bit more on this tomorrow. Tomorrow, okay, now listen to me carefully, because you have a decision to make. You have to decide when you want to learn something new. Tomorrow, right before lunch, or Friday at the end of the day. Okay? Y'all can think about it, and it's easy what we're learning tomorrow. Easy, okay? You want to come see me today? Okay. All right. All right.